Back in geometry, you learned about special right triangles. You learned about your 30, 60, 90 triangle and your 45, 45, 90 triangle. We're going to be using those triangles to help us with our trig functions. So the first thing let's talk about is in your 30, 60, 90 triangle back in geometry, you said across from a 30-degree angle could be labeled as x, and the relationship to the sides were as follows. If this was x across from your 90 degrees or your hypotenuse was the same as 2x, and across from your 60-degree angle, this leg over here, was x times the square root of 3. We're going to use those as we create our next triangle. So when we start looking at the unit circle below, one thing you have to know is as we create these triangles, our unit circle, our hypotenuse is always going to be 1 because we're going to be using the unit circle, which means the radius of our circle is going to be 1. So what we want to do is we want to come up with the same type of relationship using our 30, 60, 90 triangle. So if this is 60 degrees and this is our 30 degrees, the triangle we're going to be using is using these relationships over here. So if we know the hypotenuse, which is 2x, is equal to 1, what would be the length of the side across from our 30-degree angle? Well, we could do the math for that. All we would have to do is take 2x and set it equal to 1. Again, comparing this hypotenuse to this hypotenuse, giving us x equal to 1/2. So across from our 30 degrees, this would be 1/2. And then if we take a look at our other side that we need, this side is just x times the square root of 3. So we're taking 1/2 times the square root of 3, which is the square root of 3 over 2. This triangle right here is the triangle we will be using over and over and over again throughout this chapter to evaluate certain trig functions. The same thing goes with our 45, 45, 90 triangle. So in our 45, 45, 90 triangle, we have the relationship where if this is x, remember across from a 45-degree angle, if we have another 45-degree angle, since the angles are the same, the sides have to be the same. So this would also be x. And then the hypotenuse is x times the square root of 2. So let's use that now to create our other triangle. So if this is our original triangle, and this is 45 and 45, we need to find all our other ones, remembering that our hypotenuse, which is going to be the radius, is going to be 1. So again, we can set that up to solve for it. So we would say that the x times the square root of 2 has to be equal to 1. And to solve for x here, we would divide by the square root of 2, giving us x equal to 1 over the square root of 2. And then we rationalize that by multiplying by the square root of 2 over itself, which gives us the square root of 2 over 2. So our last side of our triangle is the square root of 2 over 2. And again, they're the same because they're both across from the 42-degree angle. And this is the triangle we want to memorize for our 45, 45, 90 triangle. And you'll see where that relates below.